Hey, what's going on today, YouTube? Sorry for the lack of uploads. I've been sick for about a week and my voice just wasn't having it. I was having a lot of coughing and I might cough sometimes during this video as well. Today, I'm going to be going over so-vits-svc 4.0, which is basically an AI model that can create or that can sing songs based on a voice that you train it with, and it can reproduce the song vocals with that voice. So I think the easiest way would be for me to show you some clips on YouTube, and then I have trained a voice model on my own voice, which is, it's okay right now. It's not the best, but it can get the meaning across. So let's go ahead, jump into some examples. And for whatever reason, there's a ton of Kanye ones on YouTube. I don't actually listen to Kanye, so I can't tell whether or not it's accurate, but let's just go ahead and give some of these a listen, and you be the judge for yourself to see how good it sounds. So here's one right here by Lucky Dejano, and it's Shake It Off.
I stay out too late, got nothing in my brain, and that's what people say. That's what people say. It's like I got this music in my mind saying it's gonna be alright, 'cause the play is gonna play, and the haters gonna hate. Well, no, I'm just gonna shake. I shake it off, shake it off.
Okay, so that was actually pretty good. I don't actually know how Kanye sounds, but that was pretty dope in my opinion. I haven't actually listened to this one, so let's just go ahead and choose one more. And I was scrolling down and I saw this Japanese song, quite a popular Japanese song, Kwaikute Gomen, and it's Donald Trump singing it. So I think everyone knows how Donald Trump sounds. So we'll go ahead and play this one and see what happens. Alright, so I've shown you some of this in action, so what the heck is it? Well, let's go ahead and take a look. Let's go ahead and head on over to the GitHub repository for SVC. And the one that I'm going to be going over today is this so-vits-svc fork. This is the one that I use, but it's based off of the main GitHub repository as well. And let's just go through a couple of things in here. So this is a fork of it with a better graphical user interface. And basically how it works is you give it a bunch of data samples of some voice, whether that be speech of it, and then you train a model on it. Then all you have to do is load in a vocal sample of a song and feed that in with the trained model, and then it'll do an inference based on the song that you gave it. So it'll use all the intonation, all of the accents that you have inside of the song, and then it'll use the voice model that you trained to create that voice model for the voice output of the song. So that is how I understand how this works. I'm no expert on it, but it's a pretty simple installation if you have some Python. And you can even do this in Google Collab. It'll just be a little bit slower as well. Basically, you set up your environment with these pip installs, and then you go down and then you get all of your data samples, put them into a folder. I'll show you all this later. And then you just run 4 lines: a SVC pre-sample, pre-config, pre-hubert, and then a train line. So this is all pretty easy to do. It looks a little bit complicated, but it's actually this part of it, the front end of it, where you're just giving it data, is actually pretty easy because we're not actually designing anything. And so a couple of notes for this type of model is that, the audio samples have to be underneath 10 seconds. So if you feed it anything that's over 10 seconds, you'll probably run out of VRAM. And that's what is going to be needed to train these models. So if you have anything lower than 10 gigabytes of VRAM, you won't be able to actually train this model on your computer, but you can always use Google Collab. So I'll show both sides of it. You can go ahead and read more of this if you want to, but I think the best way is to just jump into the code and see how it works. And today's not going to be a fully comprehensive guide on how to get this set up, just kind of an overview on how you could get it set up. So a full detailed tutorial will be coming later, but a couple of things. So you need some training data. So what I did for this was I created my own training data, and what you have to do is you have to open it up you have to upload it into your Google Drive. So here is a Google Drive right here, and so what you have to do is you create a folder called so-vits-svc-4.0, and then inside of it you create a folder called dataset, and then inside of this dataset you put in all of your data samples. So here is a folder that is me, and I have 100 samples of my voice in here that I recorded of me just saying some sentences. So if we take a sample look at one, here's one. The birch canoe slid on the smooth planks. So that is one voice sample right there. And these are some sentences that I got that are supposed to be phonetically balanced or something along the lines of that, but 100 samples. So that is what I have there. In the Collab though, once you have all that set up inside of your Google Drive, you need to set up a runtime. So for this, you just set up a runtime and make sure you have a GPU there, and then you click this little connect on the top right corner. You can't see it because I'm blocking it. Click this connect right here and it'll connect to a machine. So this is basically just connecting to a machine on Google servers. And it'll allow you to use some of the compute power. So here we go. If you don't have more than 10 or 12 gigabytes of RAM on your computer, you'll have to do it this way. So once you have that, once you have all your data in there, you can go ahead and run this right here. That's just an authorization saying that this was not curated by Google. It was created by somebody else, so only trust it if you trust it. I just clicked OK, and as you can see, we're running on a Tesla T4 from Google, which is more than enough for training this model. The other thing you're gonna have to do is mount the Google Drive. So this is basically going to give the notebook access to your Google files. Only do this if you trust it. I'm gonna say connect to Google Drive, and then it's gonna authorize it right here. So let me go ahead and do that. Alrighty, I went ahead and authorized it. While that's doing that, another thing you need to know is on this left side is your file browser. So think of it as the Windows file browser. It's just the same thing here. So inside of that you have files, and then inside of here you're gonna have your drive. So this drive is your Google Drive, and this is the top folder for it. If you click one more on my drive, then you'll see everything that's inside of here. So here we have everything that's in my Google Drive, and as you can see, we've got that so-vits-svc-4 here, and then inside you can see we've got the me dataset in there. And I'm actually going to delete this. I don't need this config anymore, this config.json. So I'm going to delete this file. I don't need it, and then close all this so we can see everything. Alrighty, so here is where it installs dependencies. So you just go ahead and run this, and it's going to install all of the dependencies, which is going to take a little bit of time. If you're on Google servers, it's going to be pretty quick. So here we go. Here we see it running. So I'll be back when that's finished. Alrighty, so we're back, and it took 1 minute to run, or about 2 minutes to run. And so once that's done, then you can head on over to this next cell, which is this. It's going to create the dataset directory that it needs for it. So that's going to be really quick. And then inside of here, you're going to want to change, the data name to what you have. So I have mine set as me. So my dataset name is me. As you can see, here is the folder structure that it wants you to have for the dataset. So let's go ahead and run this, and it's going to copy the dataset over to this little file browser on the left-hand side here. And then we'll go ahead and do this, these next couple of steps. So if we close this out, if we minimize it and reopen it up, you'll see a new folder pop up called dataset raw, and here we have the dataset. All right, so what we're going to do is just run this next cell, pre-sample. It's going to pre-sample the data, and then we'll just click pre-config as well. So that's going to create a configuration file that we can modify in order to run this. Alrighty, and so once that is done, you have your configuration file here. We're going to go ahead and change it before we copy it. So minimize and reopen it. And now we have a new folder called configs. Inside you have one called 44K, and then you've got a config.json. So when you double click into it, another screen is going to pop up here on this right hand side, and that's what we're going to adjust. And here we have some confusing numbers. There are only a couple of really important ones that you need to really focus on for training, at least to my knowledge at the current moment, which is going to be your batch size, your amount of epochs, the log interval, and then evaluation interval. Okay, so let me go ahead and explain this to the best of my knowledge, and feel free to correct me in the comments below if you know a little bit more about it, and if my explanation was wrong. So a couple of things that you need to note are the epoch count, the batch size, and then your log and evaluation interval. So the only thing that you'll probably be changing is the amount of epochs and the amount of batches. People say a good rule of thumb is to have 25,000 steps. What is a step? The step is the size of, the step is basically one batch. Say I have, in my case, I have 100 samples. If I set my batch size to 100, it's going to run through all of those 100 samples in that one batch. So that is one step. To explain a little bit more, an epoch is basically the amount of batches it takes to run through all of the data. Since I have 100 samples in this case, my batch size is set to 100. I've got 100 samples. So I'm gonna finish this epoch in one step, because per batch I'm doing 100 and I only have 100 samples. So if this was the case right now, and I want to run 25,000 steps, because my batch size is set to the amount of samples that I have in the data, I would set my epoch value to 25,000. So that would be to run 25,000 steps. Keeping in mind that I have 100 samples, what if I want to do a smaller batch size? Because the larger the batch size, the more intensive it is on your computer and the more VRAM you need. So they say that you can lower the batch size if you have less VRAM, but there's a certain amount of VRAM minimum that you have to have, and I think that is 10. So let's say I have 50. So I've got 50 for my batch size. It's going to take 2 steps to run through 100 samples of data. So what I'm going to need to do is now set my epoch value to half of 25,000, which is 12.5k. So if I go along the same lines and do 25, I'm going to need a total of half of 12.5, which is 6250. And then if I reduce it down even more, you know, you probably can't do a batch size of 12.5. And so you could keep doing it this way, but eventually we're going to end up with a batch size with a decimal point value, which we don't want to do. So basically what we would do is there's a certain formula that you can use to calculate the amount of steps that you need. And so this formula, based on my explanation, can be defined as your sample size divided by your batch size multiplied by your epochs equals the amount of total steps. So if you want 25,000 steps, move all of the variables over to the other side, and you can find out your epoch by algebra. So now if you don't want to do any of that algebra, which is okay, you can just go ahead and leave this at 10,001, and then set your batch size to a small number. If you have low VRAM, you can do 16. In this case, I'm going to go ahead and set it to 50 and see how that runs. That's your config.json. We're going to go ahead and control save that. And to do that, you just click Control S and it's going to save it. And then we're going to go ahead and close this JSON. And then now we're going to go ahead and copy this configs file. So you just click copy configs. And then the pre-Hubert that we're going to use here, I actually don't know what F0 stands for. I have to go take a look. We're going to use the crepe model. I hear it generates a little bit more human-like voices, and we go ahead, or less robotic voices, and we go ahead and run this. And it's going to go ahead and run through pre-Hubert. This is weird. It is not giving me what it had before. It should list out a bunch of things that occurred. So we're gonna go ahead and run it again already. And I guess maybe that's what it's going to do. So on the collab, so I guess we can just go ahead and run train, and then we should be good to go. So we just run this last cell, and it's going to go ahead and start running the training portion of the model. So we'll see if it can run it. As you can see, this didn't actually run because there was something wrong with this pre-Hubert step here. So we're gonna go ahead and actually lower this. We're gonna lower my batch size here. and we're gonna do 16 because we are running on a collab, and I don't know if it can use all, if it can do 50. So we're gonna do 16 for P-Hubert and see if we get a different result. All right, so it doesn't seem to be working correctly, so we're just gonna go ahead and stick it back to DO and try running it this way. Okay, so I tried one other thing, which is to do -N2 and then lower the batch size. So we're supposed to get a lot more of this. It should go all the way to 100%, so I don't even think this train is going to run correctly. So if it doesn't run here on the collab, it may be a glitch happening. I'm not sure what happened because I was able to run this last week, but maybe something changed. Okay, so lo and behold, it actually is training here. So I thought it wasn't going to train, but yeah. So let me show you what it's supposed to look like. So here I have it in VS Code already. When it does P-Hubert, it should reach 100% here for the model. Okay, and so yeah, it should reach 100% for the pre-Hubert, you know, if you're running it, but maybe that's just my limited knowledge of this. But as you can see, it is running here. It is running at what did I set it at? Running at a batch size of 6. So it's slowly moving through it. As you can see, it's got 17 steps right here. So this is 17 steps that it has to do. You get the 17 by dividing 100 by 6. So if you divide 100 by 6, and so what it does is it rounds up to the nearest whole integer. So if you have 16.1, it's going to round up to 17. So you have 17 steps inside of your epoch, and it's going to train the model as it gets going. So good to know that in order to train it on Collab, you still have to run -N2, and that is how you get the Collab running for a voice model. And it's going to take longer depending on how many sample sizes you have and whatnot. So with that out of the way, with Collab out of the way, I'm going to go ahead and show how you can run it if you have a graphics card that can support it with the amount of VRAM. So let's go ahead and head on over to and so the same way that you did it in Collab, you can also do the exact same thing using VS Code. So I'm not going to go through the entire steps you need to do this, but basically what you do is you clone the repository. So here it is, so-vits-svc-4.0. Do this installation here. So that is what I did inside of my VS Code terminal here. You run all of these pip installs. I recommend that you do it inside of a Conda environment or inside of a virtual environment. And if you need to set up a virtual environment in VS Code, it's pretty easy. All you do is Control-Shift-P and then Python create environment and choose one of these environments here. And that'll make sure that you don't have any package like conflicts or anything like that. And then all you have to do is do the exact same thing, you know, get all your data into the right spots. So inside of this so-vits-svc-4.0 folder, all you need is a folder called dataset raw. And so here we have the me folder here. And then when you run those commands, you're going to do your pre-sample, your pre-config. The pre-config, you're going to end up with a configuration file that you're going to configure the exact same way. So I'm running a batch size of 50 here. And then, you know, you do the pre-Hubert and then you run train. So when you train it, it should continue running. So I will probably train my model for a little bit longer. I might need to add some more data samples and just run it entirely again. So I'm not going to train it on video because it's going to not allow me to record. We'll just go ahead and jump into the demonstration part of my voice. So let's go ahead and do that. So if we're in the folder, we could just shift right click and then click open in terminal. And then we could just type in svcg, so svc GUI. And it's going to open up this graphical user interface right here. So what we're going to do here is we're going to go over to browse and we're going to search for the model path. So the model path for this is actually inside of so-vits-svc-4.0, logs 44k, and then your latest G model. In my case, it's going to be 10,001. So I opened that. The configuration is going to be in the same folder, logs 44k, and the config.json. And then your audio path is going to be the audio file or the song that you want to turn your voice into. So here I have some songs and I extracted out the vocals for them. So we have plain white tees. Hey there, Delilah. Let's go see. Here are the vocals. So we'll go ahead and play that, put that there. We're going to change my octave down to, well, let's just do 0 and then see how that sounds. Turn off autoplay, turn it down to crepe. And then we're going to go ahead and just click infer here. So I'm going to use my GPU by selecting this use GPU option, and then I'm going to infer. So it's going to take a couple of seconds. If I open up this window here, you can see that it's running through the inference, and it'll tell me when it finishes up. So this will vary depending on your GPU. So just wait for it to finish, and here we go. It's finished, and it's going to be inside of that folder. So, and let's go ahead and take a listen.
Hey there, Delilah, what's it like in New York City? I'm 1,000 miles away, but girl, tonight you look so pretty, yes you do. Times Square can shine as bright as you, I swear it's true. Oh, it's what you do to me. 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 What you do to me.
All right, we're gonna go ahead and stop it there. As you can see, it's not perfect. There are hiccups. It does sound a little robotic, and so that comes with more training, adding more data. There is no science to it, and usually throwing it more data and training it for longer generally results in better results. And this also works in other languages as well. So here we are, and if we go ahead and play this, it'll be Japanese.
To thy welcome, no milada, sky through and blue, career push my bro, kairi desu my
Okay, so yeah, it kind of broke. That's all I wanted to go over today. I didn't do a full comprehensive tutorial on it, but if you'd like to see that, let me know down in the comments below. This is something that I just got really interested in the last couple of weeks, and I haven't been really working on the other stuff, but I have some stuff that I need to work on for Vivi, so expect some videos for Vivi, the voice assistant, coming out soon. And yeah, I will be gone next week, so I won't have too much content next week either, but that's gonna be today's video. See you around later, and if you have any questions, let me know down in the comments below.